Today I'll solve a system of linear equation using Gauss Elimination Method. The system contains 3 equations and 3 variables. So here are the equation: 5x minus 2y plus z is equal to 4, 7x plus y minus 5z is equal to 8, 3x plus 7y plus 4z is equal to 10. Here our objective is to reduce this system to an upper rectangular matrix and then apply back substitution to find the values of x, y and z. Now the first step is to write the augmented matrix form. So here are that coefficient of that equation. So we have to write that coefficient as a matrix form. So from that first row we'll get from the first equation, from second equation we'll get second row, from third equation we'll get third row, and these are the constant matrix b1, b2 and b3. So here you can see from this equation the right hand side 4, 8 and 10 are the constant matrix. So these are the augmented matrix form. So our target is that we have to make this element 0, this element 0 and this element 0. For that we have to do the row operation. So now here our aim is to eliminate this and this element become 0. So for that, to eliminate that this a21 and a31, we have to use this equation ri, that will be ri minus ai1 by a11 by r1. I here is 2 and 3 because we are doing the operation 2 and 3. So now, so here, so applying this to our matrix. So here R2 minus 7 by 5. What is 7? 7 is that I is 2 1 by a1. So that is nothing but for a 2 1 by a11. So that is nothing but 7 by 5. a21 is 7 and a1 is 5. So 7 by 5 into r1. And here r3, if I want to make this element 0, so we have to do the operation. So here r3 minus again a31 by a11, that is 3 by 5. So r3 minus 3 by 5 r1. After getting that constant, we will do the row operation. So now here, so we are going to make this element 0. So for that we have to do 7 minus, we got that 7 by 5 into 5. So that will be 0. So this will be 0. Now second means a22 double dash, means after doing the operation the element will change, means a22 element will be changed. So a-22 will be a22 minus a21 by a1 by a12. So here a22 is 1 minus 7 by 5 into r1. r1 means here a12, so that is minus 2. So if we do the calculation, we'll get 3.8. Similarly, this element a23 dash, so a23 minus a21 by a1, a13. So a23 is minus 5, a21 that is 7, a11 5 into a31 that is 1. So that will be minus 6.4. And then we have to change that constant matrix also. So b2 dash is equal to b2 minus a21 by a1, b1. So that will be nothing but 8 minus a21 is then 8 minus 7 by 5, b1 is nothing but 4. So if I do the calculation, we will get 2.4. Now after doing that calculation, that updated matrix will be 5, means first row will be as it is, second row that element will become 0, means 7 becomes 0. So 0, then after operation we will get that a dash 22, that is 3.8, then a23 dash minus 6.4 and b2 dash is 2.4, and now the third row is as it is. Now next step is we have to eliminate this element, and this element becomes 0. Now for that, so we have this. Now we have to do this element, means 3 minus 3 by 5 into 5, so that will be 0. And then we have to do the operation. So this element will change. So a32 will be a32 minus a31 by a1 into a12. a32 is 7, then minus 3 by 5, then a12 is minus 2. So if I do that, 7 plus 1.2, that is 8.2. Similarly, a33 minus a31 by a1 into a13. So a33 is 4 minus 3 by 5 into a13 is 1. If I doing the operation, after doing the operation, we'll get 4 minus 0.6, that is 3.4. Similarly, now for the constant matrix b3 dash, so b3 minus a31 by a1 1 into b1. So b3 is 10 minus 3 by 5 into b1 is 4. After doing the calculation, we'll get 7.6. So now after updated matrix, after eliminating a31 and a21, we'll get 5 minus 2 1 4. So earlier it was the pivot element. Now we got 0 3.8 minus 6.4 2.4, and then 0 8.2 3.4 7.6. Now we have to remove this element, so this element will become the pivot element. So for that we have to do to eliminate a32, we use r3 is nothing but r3 minus a32 by a22. a32 is nothing but 8.2, a22 is 3.8. So r3 minus 8.2 by 3.8 into r2. So if we do the operation, it will automatically 0. Now we have to do this and this. So this element will be a double dash 3.4 minus 8.2 by 3.8 into minus 6.4. After doing the operation, we'll get 17.2. And b3 double dash will be 7.6 minus 8.2 by 3.8 into 2.4. So that will be 7.6 minus 5.18, nothing but 2.42. Now after plugging all this value, so we'll get 5 minus 2 1 4, 0 3.8 minus 6.4 2.4, 0 0 7.2 and 2.4. So now if you see, so this become the upper rectangular matrix. So now here that matrix, after all elimination, we will get that upper rectangular matrix. So now we will do the back substitution. So for here we got that matrix, upper rectangular matrix. This is the upper rectangular matrix. Now we are going to do the back substitution. So first solve this one, means x3. x3 is nothing but z. So 7.2 into x3, because here that is 0 into x1 plus 0 into x2 plus this. So this is nothing. So 17.2 x3 is equal to 2.42. So x3 is nothing but 2.42 divided by 7.2, that is 0.1407. So that is nothing but z. After getting that, from the second equation we'll find the x2. So 3.8 into x2, because 0 into x1 plus, so this is nothing. So 3.8 x2 minus 6.4 x3 is nothing but 2.4. So x2 will be 2.4 plus 6.4. Now we got that x3 value. We plug that 0.1407 by 3.8, we'll get 3.3 by 3.8, so 0.8684. Now from this first equation we'll get the x1. So 5x1 plus minus 2x2 plus x3 is equal to 4. So x1 is nothing but 4 into 2 into that x2. x2 is 0.8684 minus 0.1407, because here x3 we are plugging that, and we'll get 5.596 by 5. So that is nothing but 1.1192. So ultimately x1, x2 and x3 is nothing but 1.1192, 0.8684, and x3 is 0.1407. So after that we'll get all this x1, x2, x3, that is a solution vector, means here x1 is nothing but, this is nothing but x, y and z. So x, this is nothing but x, this is nothing but y, this is nothing but z. After doing the Gauss elimination method, we'll get the solution. So x is equal to 1.1192, y is nothing but 0.8684, and z is nothing but 0.1407. So we have successfully reduced the system and computed the values of unknowns. That's it. Thank you.